Hello students, in our DME class, we were discussing about rolling contact bearings and we have covered some of the basic concepts like life of a bearing, rating life, basic dynamic load rating, dynamic equivalent load and its formulas. So today we will discuss an important numerical from the topic of rolling contact bearings. Before starting the numerical, you have to understand these formulas. So this is W is equal to X V WR radial load plus Y into WA, that is axial load, where load factor X and load factor Y, we will take these values from the table. This is the formula for the life of a bearing and this is the formula for basic dynamic load rating, which is very important formula, and this formula will be used in the numerical. You should understand that this K, small k, is equal to 3 for ball bearings, and we will use this in our numerical. This is the table which will be helpful in solving the question, and this table you can find in the data book VK Jadon, or you can say PSG Coimbatore. So let's start the numerical. This is the statement. Select a single row deep groove ball bearing for a radial load of 4000 Newton and axial load of 5000 Newton, operating at a speed of 1600 rpm, an average life of 5 years at 10 hours per day. Assume static load rating value 10 kilonewton and suitable number of working days. So this is the statement, and this numerical is very important. So we write the given data. Radial load 4000 given, axial load 5000 given, RPM 1600 given, average life 5 years at 10 hours per day. Means your bearing has a life of 5 years if it is working at 10 hours per day. Therefore, life of a bearing in hours. Now see this, if we have 300 working days per year, then 5 into 300 into 10, because it is working at 10 hours per day. So 10 hours per day, total number of days 300, we multiply them, and how many years? 5 years. So this is the number of hours which represents the life of the bearing. So 15,000 hours is the life of your bearing. And life of a bearing in revolutions. So this is life of a bearing in hours. Now life of a bearing in revolutions. So you can see in 1 minute your bearing rotates at 1600 revolutions. So in 1 hour it will rotate at 60 into 1600. And how many hours it have to rotate? 15,000. So we multiply these three terms, and this is the number of revolutions for which your bearing will rotate, or we can say this is the life of a bearing in terms of revolution. Now we will apply the formula basic dynamic equivalent radial load W x V W R plus Y W A. The values of x and y, we will take it from the table. For this, we have to find WA by WR and WA by C naught, because in the table you can see if you have to find x and y, then you should know WA by WR and WI by C naught. If these values are known to you, only then you can find x and y. But WA by C naught, we haven't given the value of C naught, so this is our assumption. C naught we will assume from our side. Whereas WA and WR is given to us, so there is no problem. But WA by C naught is not given, so this we will assume from our side. So you can see, since the value of basic static load capacity is not known, C naught is not known, therefore let us take WA by C naught 0.5. So we assume it from our side. And WA by WR, we put the values and it is 1.25. So let's see the table. So WA by C naught, we have taken 0.5 assumption, and WA by WR, which is 1.25 and which is greater than E. E is 0.44. So therefore in this column we will take X and Y. X is 0.56 and Y is 1. So let's take the value of X 0.56 and Y is equal to 1. Now X we have taken from the table, Y we have taken from the table. Now rotational factor for the most of the bearing can be taken as 1. So this V is equal to 1, and now put the value of WR, WA, X, Y and V to calculate W basic dynamic equivalent radial load. So W will be 0.56 into 1 into 4000 plus 1 into 5000. So it comes out to be 7240 Newton. From table, we find that for uniform and steady load, the static service factor Ks for ball bearing is 1. So you can see for uniform and steady load, service factor is 1. So Ks will be 1. So we will design the bearing for 7240 Newton load. Now in the next step, we will calculate basic dynamic load rating. We can say the value of C, and C is equal to W L by 10 raised to power 6 raised to power 1 by K. W 7240, L life of the bearing in revolutions, this we have earlier calculated, upon 10 raised to power 6, 1 by K is 3. So C comes out to be 81760 Newton, or we can say 81.76 kilonewton. Rest of the numerical we will discuss in the next video. Thank you guys. Stay tuned.